In this video, we're going to look at quotients of monomials and then zero exponents and negative exponents. So basically two things we want to get out of this. We want to be able to simplify quotients using the laws of exponents, and then simplify expressions that involve an exponent of zero and or negative integer exponents. So previously we learned how to add and subtract monomials and how to multiply monomials. So what we're going to look at now is how to divide two monomials. All right, so way back in the land of arithmetic, we learned that if you want to multiply two fractions together, you just multiply the numerators and then multiply the denominators. So if I want to take 3/5 times 4/7, I would just take the 3 times the 4 to get my new numerator, which is 12, and then 5 times 7 for the denominator to get my new denominator, 35. So 3/5 times 4/7 ends up giving us 12 over 35. So in general, if you want to multiply two fractions together, you're going to end up just taking the top times the top and the bottom times the bottom. So if P, Q, R, and S are all real numbers, and Q is never 0 and S is never 0, then the rule to multiply fractions would just be, if you have a fraction like P over Q times R over S, you would just take P times R, so the numerator times the numerator, and then Q times S, so the denominator times the denominator, would get you your product. So turns out that little rule from arithmetic allows us to simplify monomials. So let's say you have PR divided by QR. Well, using our rule for multiplying fractions, that would be P over Q times R over R. Well, anything divided by itself simplifies to 1, the multiplicative identity. So R divided by R is just 1, and P over Q times 1 is P over Q. And keep in mind, Q and R would not be allowed to be 0, because you can never divide by 0. So this is going to let us simplify ratios of monomials. So when we divide two monomials. So for example, let's say we want to simplify the following. So in A, let's simplify 30 divided by 48. So that would be the same thing as, let's see, 30 is 5 times 6, and then 48 is 8 times 6. So we would write that as 5/8 times 6 over 6. And 6 over 6 is just 1. So we end up with 5/8 times 1, which is just 5/8. So 30 over 48 simplifies to 5 divided by 8. So notice I split it up using the greatest common factor. So 6 is the greatest common factor of 30 and 48. Okay, so make sure this is the greatest common factor. So let's use the same idea for some algebraic monomials. So I've got 9x times y cubed, all divided by 15, x squared, y squared. So let's split this up using the greatest common factor. So the greatest common factor of 9 and 15 is 3. And then the greatest common factor of x and x squared is x. And the greatest common factor of y cubed and y squared would be y squared. So 9 we could write as 3 times 3. Let's do it this way. So the greatest common we said would be 3. So 3 is the greatest common factor of 9 and 15. And then for x, this has 1x, this has 2x's. So it would be 1x, and this has 2y's. This has 3y's, and this has 2y's. So they have 2 in common. So if the greatest common factor is 3xy squared, then we can write 9xy cubed as 3 y times 3xy squared. So this is the greatest common factor, and then 3 times 3 is 9. Y times y squared is y cubed. And then denominator, to get 15, we're going to need a 5. And then we had 2 x's and then a y, so it would be... So if you look, here's the greatest common factor, 3xy squared, 3xy squared. And then 3 times 3 gives me the 9. Y squared times y gives me the y cubed. And on the bottom, 3 times 15 gives me the 15. X and x gives me the x squared, and then the y squared. So this would be 3y divided by 5x times 3xy squared divided by 3xy squared. But anything divided by itself simplifies to 1. So this would be 3y over 5x times 1, which would be 3y divided by 5x. So this expression simplifies down to 3y divided by 5x. Alright, so before we move forward, we're going to want to make sure we know all our exponent laws. So we looked at a few of these earlier, and we're going to add to it now. So our laws for exponents, keep in mind for all of these laws that m and n will be positive integers. So they're not negative, and they're not fractions or decimals or anything. They're just positive integers. And then a and b can be any real number you want them to be. So some of these are going to look familiar because we talked about them earlier. So if you have a to the m times a to the n, since they have the same base, you keep the base and you add their exponents. So you get a to the m plus n. So that's one of our old ones. If you have a times b, that whole thing raised to a power, in this case m, each thing in the parentheses gets the exponent. So it'll be a to the m times b to the m power. That's another old one. And then our last old one is if you have a to the m and it's all being raised to the n power, some other power, then you multiply those exponents. So it would be a to the m times n. So those are our old ones. We're going to add to them now. So let's say we have a fraction being raised to a power. So a divided by b all raised to the m power. Then the numerator gets the exponent and the denominator gets the exponent. So that's one we haven't seen yet this year. Let's say you have two expressions both with the same base. So I've got base A, but they have different exponents. So they could be the same exponent. It works the same way. But let's say you have a to the m and it's being divided by a to the n. So notice they have the same base. You keep the base and then you subtract their exponents. So it'd be m minus n. So when you multiply two things with the same base, you add the exponents. But when you divide two things with the same base, you subtract their exponents. Well, let's say you have a negative exponent. If you have a negative exponent, a to the negative n over 1, you end up just flipping the fraction and making the exponent positive. So it'll be 1 divided by a to the n. Well, let's say your negative exponent's in the denominator. So you have 1 divided by a to the negative n. You flip the fraction and make the exponent positive. So it'd be a to the n divided by 1. Let's say you have 0 as your exponent. So any number to the 0 power is just 1. So any number to the 0 power is just 1. Keep in mind, though, 0 to the 0 power is undefined. So you can't divide by 0, and that's undefined, and so is 0 raised to the 0 power. That's undefined also. All right, so these will let us simplify fractions. So let's give this a whirl. So let's say we have 2 to the 8th power divided by 2 to the 5th power. Well, they're both base 2, so using one of our new rules, we'll keep the base, and then we'll subtract the exponents. So I end up getting 2 to the 3rd, which is just 8. So 2 to the 8th divided by 2 to the 5th is just 8. Well, what if I have some variables? So let's look in this case. We have 5x to the 3rd divided by x to the 7th. So that would be 5 over 1 times x to the 3rd over x to the 7th, which would be 5 over 1. And then we have the same base, so we're going to subtract the exponents. So it would be x to the 3 minus 7, which would be 5 over 1 times x to the negative 4th. So that would be 5 over 1 times x to the negative 4th over 1. And we have a negative exponent, so we flip that fraction and make the exponent positive. So it'd be 5 over 1 times 1 over x to the 4th. And then we just multiply those fractions together. So we get 5 over x to the 4th. So 5x to the 3rd divided by x to the 7th ends up being 5 divided by x to the 4th. Let's try some other ones. So this first one, we got y cubed divided by 3, and that whole thing is being squared. So we have a fraction that's being squared. So the numerator and the denominator both get that exponent. So the numerator gets that exponent, and the denominator gets that exponent. And now we have a power raised to another power, so we're going to multiply those exponents, and then 3 squared is 9. And you can write this as y to the 6th over 9, or if you want, you could write that as 1/9 y to the 6th. Both of those would be acceptable, whichever way you want to write that. So let's look at this next one. This next one, we've got 24s to the 4th, t to the 3rd, 32s times t to the 5th. And we want to simplify that. So it would be 24 over 32 times s to the 4th divided by s times t to the 3rd divided by t to the 5th. So let's start to simplify that. So 24 and 32, their greatest common factor would be 8. So it would be 3 times 8 divided by 4 times 8. And then s to the 4th divided by s would be s to the 4 minus 1. And then t to the 3rd divided by t to the 5th would be t to the 3 minus 5. And then that would give us 3/4 s to the 3rd, and then t to the negative 2 power. But now we have a negative exponent, so we're not simplified yet. So that would give us 3 to the 4th times s to the 3rd over 1. And then we have a negative exponent, so we're going to flip that fraction and make the exponent positive. And then we multiply that all together, and we get 3s to the 3rd divided by 4t squared. Keep in mind, s and t can't be 0, because then you would have division by 0. So if s was 0, the whole denominator would end up being 0, and you can't have division by 0. Same thing with t. So if t was 0, the whole denominator would be 0. Can't have that. Let's try a couple other ones here. So we have another fraction, and it's raised to the negative 3rd. So that'd be 2 to the negative 3. So the numerator and the denominator both get that exponent. And then we have 2 to the negative third divided by 3 to the negative third. So that would be the same thing as 2 to the negative third over 1 times 1 over 3 to the negative third. And then we flip the fractions and make the exponent positive. So it'd be 1 over 2 to the third times 3 to the third over 1. And then we multiply that back together. So that would give me 27 over 8. And there's no greatest common factor with 27 and 8, so that's as simplified as we're going to get. For this next one, remember y can't be 0, because if y was 0, then the whole denominator would be 0, and we're never allowed to divide by 0. So for this one, we have this fraction raised to that power. So the numerator gets that exponent, and the denominator gets that exponent. And then notice we have a lot of stuff being raised to the negative 1. So everything inside gets that exponent. And then now we got to use our negative exponent rule here. So this would be, let's see, we'd have 2 to the negative 1 over 1 times 1 over 5 to the negative 1 times, let's see, we'd have x squared and then 1 over y to the negative third. And then we'll use our negative exponent rule where we flip the fraction and make it positive. So that would be 1/2 times 5 over 1 times x squared over 1 times y cubed over 1. And we just multiply that all back together. So we end up with 5x squared y cubed all divided by 2. Alright, let's do one more. B can't be 0 in this case, and we'll see why here in a second. So 2 to the negative 1, we would flip that, make the exponent positive. Anything to the 0 power is 1. And b to the negative 3, we're going to flip that, make it positive. And that's why b can't be 0, because you'd have 0 cubed, which would give you division by 0, and that's never allowed. So multiply those all back together, and you get 1 over 2b cubed.